Today, in this video, we will see numerical on tensile test. Numerical is the following observations were made during a tensile test. On a mild steel specimen 30 mm diameter and 200 mm long, limit of proportionality is 40 kN, corresponding extension 0.054 mm, yield point load 90 kN, ultimate load 140 kN, length of specimen at fracture 241 mm, determine Young's modulus of elasticity, yield stress, ultimate stress, percentage elongation. For that mild steel specimen, stress strain graph is strain, x-axis strain, y-axis stress, point A is limit of proportionality. After this point A, point B, elastic region, elastic limit point. This point B, elastic limit point. After this point B, point C, yield load point. Point D, lower yield point. This point E is ultimate load point, and this point F is fracture point. Data: mild steel specimen 30 mm diameter, small d is equal to 30 mm and 200 mm long. Diameter of that mild steel specimen is 30 mm and length is 200 mm. Load at limit of proportionality. Load at this limit, this point A, load at this point A is 40 kN, and up to this point B, elastic limit point, there is elastic region. That's why this is load at elastic limit, and load is denoted by P. Therefore, PE is equal to 40 kN, and corresponding extension for that load at limit of proportionality denoted by delta L is equal to 0.054 mm, 0.054 mm, corresponding extension. Yield load point, this point C is upper yield point and load at this point is 90 kN. Py, load at yield point, is 90 kN. Py is equal to 90 kN. Ultimate load point, this point is ultimate load point. Pu, ultimate load, is equal to 140 kN. Length of specimen at fracture 241 mm. This F is fracture point and length of specimen at fracture 241 mm. Length of specimen is 200 mm and length of specimen at fracture is 241 mm. Length of specimen is denoted by L and length of specimen at fracture is denoted by L dash is equal to 241 mm. Now determine Young's modulus of elasticity. Young's modulus of elasticity is denoted by E, and formula for Young's modulus is stress upon strain. Stress is denoted by sigma and strain is denoted by E. Stress is load upon area and strain is change in length upon original length. P by A multiplied by L by delta L. Hooke's law is stress is directly proportional to strain, and stress upon strain is equal to constant, and this Young's modulus is stress upon strain. So up to this elastic region, this Young's modulus and Hooke's law obeyed. That's why take load P at elastic limit point. P is equal to 40 kilonewton. 40 kilonewton, and convert it into Newton, multiply by 10 raised to 3, and length of that specimen is 200 upon area of that bar. Diameter of bar is 30 mm and area of that bar is pi by 4 into 30 square, multiply by change in length. Change in length is 0.054. Load at limit of proportionality 40 kilonewton and corresponding extension is 0.054 mm. 0.054. Calculation. (40 into 10 raised to 3 multiply by 200 upon pi by 4 into 30 square, 706.85 multiply by 0.054. 40 into 10 raised to 3 multiply by 200 divided by 706.85 into 0.054. 209.58 into 10 raised to 3. Young's modulus. This Young's modulus of elasticity formula is stress upon strain, and stress unit is Newton per mm square, and strain has no unit, and Newton per mm square, 1 Newton per mm square, 1 Newton per mm square is equal to 1 MPa. So 209.58 into 10 raised to 3 MPa. This Young's modulus of elasticity is 209.58 into 10 raised to 3 MPa. Next, determine yield stress. Stress is load upon area and yield stress is yield load upon area, and yield load is 90 kilonewton. So second, determine yield stress. Stress is denoted by sigma and yield y, sigma y. Determine sigma y. Sigma y is equal to load upon area. And which load? Up to yield point load. And this yield point load is 90 kilonewton. 90 kilonewton, convert it into Newton, 90 into 10 raised to 3 upon area of that 30 mm diameter bar is 706.85. Into 10 raised to 3 divided by 706.85, 127.33. and stress unit is Newton per mm square. This load is in Newton and area is mm square, and Newton per mm square is MPa, so yield stress comes 127.33 MPa. Next, calculate ultimate stress. Similarly, yield stress, ultimate stress is also ultimate load upon area, and load at this E point, ultimate load point, PU is 140 kilonewton. 140 upon this 706.85, we get ultimate stress. Calculate. 3. Ultimate stress sigma u. Sigma u is equal to load upon area, ultimate load upon area. Ultimate load is 140 into 10 raised to 3 Newton. 140 into 10 raised to 3 upon area of that 30 mm diameter bar, 706.85. 140 into 10 raised to 3 upon 706.85, 198.06 MPa. Yield stress is 127.33 MPa and ultimate stress is greater than this yield stress. Ultimate stress is 198.06 MPa. Next, calculate percentage elongation. Percentage elongation is formula for that percentage elongation, final length minus original length upon original length. So length of specimen at fracture is 241 mm. This is final length, and our specimen length is 200 mm. This is original length. Percentage elongation formula is final length minus original length upon original length. Final length is 241 mm minus original length is 200 mm upon original length 200 mm, and elongation is in percentage, multiply it by 100. So percentage elongation 241 minus 200 upon 200 into 100, 20.5%. So see that mild steel specimen 30 mm diameter and 200 mm long, Young's modulus is 209.58 into 10 raised to 3 MPa. Yield stress is 127.33 MPa. Ultimate stress is 198.06 MPa, and percentage elongation is 20.5%. That means yield stress at this E point 198.06. MPa. Stress is in MPa. And yield stress 127.33. Yield stress is up to point C 127.30. So see, load at this ultimate point is 140 kilonewton and stress at this ultimate load point is 198.06 MPa, and load at this yield point is 90 kilonewton and stress at this yield point is 127.33 MPa, and Young's modulus is 209.58 into 10 raised to 3 MPa, and percentage elongation is 20.5%. Thank you very much.